The light you would see in the last moment has already left its source. It left before you were born, before your civilization was born, before the first human being drew breath. It has been crossing the dark between stars for thousands of years, and it does not know you exist, and it is not slowing down. When it reaches you, it arrives at the speed of light. There is no signal faster. No telescope can detect it before it arrives because the signal and the threat are the same thing. The light is the danger. The moment you see it is the moment it is already here. This is the property of gamma-ray bursts that places them outside every other threat in the known universe. Every other danger in this galaxy can be seen coming. A comet can be tracked for decades. A dying star can be observed for centuries. Even the expansion of the universe, which will eventually strand this galaxy in an empty void, can be measured and predicted centuries before it matters. A gamma-ray burst cannot be predicted. It cannot be seen approaching. The warning and the event are the same thing, traveling at the same speed. And there is a star in this galaxy right now that may be preparing to send one in your direction. On March 19, 2008, a point of light appeared in the constellation Boötes. It was briefly visible to the naked eye, unaided by any telescope or instrument. Just human eyes looking up on a clear night at the right patch of sky at the right moment. The source of that light was 7.5 billion light-years away. That event was GRB 080319b, a gamma-ray burst detected on March 19, 2008, cataloged as the second of that date, one of the most energetic explosions ever recorded in human history. In those seconds, GRB 080319b released more energy in gamma rays alone than the sun will emit across its entire 10 billion year lifespan. The burst lasted roughly 30 seconds. Every nuclear weapon ever built, every volcanic eruption in geological history combined represent a fraction of the energy a single long gamma-ray burst releases in that span. And one went off visible to the naked eye from 7.5 billion light-years away. The question is not what happens when one fires at that distance. The question is, what happens when one fires inside your neighborhood of stars? Gamma-ray bursts arrive in a narrow beam. The jets produced by long gamma-ray bursts typically span a few degrees of arc in half-opening angle. This is the feature that has, until now, protected Earth. Many gamma-ray bursts that fire within the Milky Way have their jets aimed elsewhere. They discharge, they dissipate, and we do not know they happened. But that word, many, carries the weight of everything. The type of star that produces a long gamma-ray burst is called a Wolf-Rayet star. It is a massive star in its final stage of life. It is burned through its hydrogen, stripped its outer layers in intense stellar winds, and left behind a hot, dense, unstable core of helium, carbon, and oxygen burning at tens of thousands of degrees. It is dying at a rate that, on astronomical timescales, is rapid. When a Wolf-Rayet star collapses, if conditions within the core produce the right rotational dynamics, the collapse does not simply produce a supernova. It produces a hypernova. And from the poles of the collapsing star, a pair of jets of gamma radiation and X-rays launches outward at nearly the speed of light. Each jet is a few degrees wide. Each jet is aimed in whatever direction the star happens to be spinning when it dies. The galaxy contains thousands of Wolf-Rayet stars. They are the terminal stage of stellar evolution for the most massive stars. Many will never produce a gamma-ray burst. Some will. We cannot know in advance which ones. When a gamma-ray burst strikes a planet with an atmosphere, the primary destruction does not come from the direct radiation dose to the surface. It comes from what the radiation does to the sky above you. Gamma rays and X-rays carry enough energy to ionize the nitrogen and oxygen molecules in the upper atmosphere. This ionization drives chemical reactions that produce nitrogen oxides, primarily nitric oxide and nitrogen dioxide. These compounds are ozone killers. Each nitrogen oxide molecule can catalytically destroy thousands of ozone molecules through a chain reaction before being neutralized. The ozone layer is what stands between life on this planet and the lethal ultraviolet output of the sun. Without it, or with a significantly reduced version of it, surface life is exposed to UV intensities that many of the organisms which evolved over the past 400 million years cannot survive. In the hemisphere of Earth facing the burst, the depletion would begin within hours. Research models, including work published by Brian Thomas, Adrian Millot, and colleagues, estimate that a gamma-ray burst at a distance of roughly 6,500 light-years, if aimed directly at Earth, could destroy approximately 35% of the ozone layer on a global scale. The hemisphere facing the source would experience more severe and more rapid depletion. At shorter distances, the damage scales accordingly. The consequences descend from the sky. Phytoplankton, the microscopic organisms living in the surface layer of the ocean, produce roughly half of Earth's oxygen and form the base of marine food chains. They are sensitive to ultraviolet radiation. A sustained increase in UV exposure kills them in large numbers. When phytoplankton populations collapse, the marine food web loses its foundation. On land, elevated UV damages plant DNA directly. Reduced plant growth removes the base of terrestrial food chains. The atmospheric nitrogen oxides also cause cooling as they partially block sunlight. What begins as a radiation strike becomes something colder and darker in the months that follow. The ozone layer is approximately 3 millimeters thick when compressed to sea level pressure. That is the total substance of the shield. 3 millimeters of chemistry, and it has kept the surface of this planet habitable for hundreds of millions of years. A gamma-ray burst does not know how long it took to build. Consider where the math has already landed. In 2004, researchers published a hypothesis proposing that the late Ordovician mass extinction, one of the largest in Earth's history, may have been triggered by a gamma-ray burst. The late Ordovician extinction occurred approximately 443 million years ago. It eliminated an estimated 85% of all marine species. It is the second largest extinction event in Earth's fossil record. The hypothesis, proposed by Brian Thomas, Adrian Millot, and colleagues, observed that the extinction pattern is consistent with what a GRB-induced ozone depletion event would produce. Marine species in shallow, sun-exposed waters were hit hardest. Deep water organisms, shielded from surface UV, survived at higher rates. The event was also associated with a rapid global cooling, consistent with secondary atmospheric effects of a large-scale radiation strike and the nitrogen dioxide chemistry that follows. This is a hypothesis. It is not established fact. The researchers presented as one possible mechanism among several proposed causes, all of which have scientific support. But the pattern fits. And the fit matters because it suggests the universe has already aimed one of these at Earth and fired. Not in a theoretical framework, not in a model output, in the actual fossil record, in the actual history of life on this planet. The gun has been fired before. The 85% vacancy in the fossil record is what that looks like. If this channel is where you go when the universe needs to be honest with you, subscribe. What comes next is where the threat stops being historical. 8,000 light-years away, in the direction of the constellation Sagittarius, there is a binary star system called WR104. One component is a Wolf-Rayet star. The other is an O-type star, a hot, massive companion. They orbit each other every 220 days, producing a distinctive pinwheel pattern of gas and dust that has been imaged and studied. The Wolf-Rayet component is in an advanced stage of terminal evolution. Its core is approaching the conditions required for collapse. When it goes, it may produce a long gamma-ray burst. The rotation axis of WR104 has been measured. It is estimated to point within approximately 16 degrees of Earth. 16 degrees requires context. The half-opening angles of gamma-ray burst jets typically range from roughly 5 to 15 degrees, with significant variation across observed events. If WR104 produces a burst toward the narrower end of that range, Earth may sit outside the primary cone of destruction. If the jet is broader, or if the axis alignment is more precise than current measurements indicate, Earth is inside it. The measurement carries uncertainty. The distance, approximately 8,000 light-years, places WR104 at or near the outer edge of the estimated range for significant ozone damage. These facts mark the precise boundary of what science can currently say. WR104 has appeared in peer-reviewed astronomical literature precisely because the combination of proximity, Wolf-Rayet classification, and axis alignment makes it worth examining. That is the honest summary. The system is real. Its distance is real. Its axis has been measured. The result is close enough to warrant dedicated attention from researchers who study exactly this category of threat. And if it fired tonight, the radiation would take 8,000 years to arrive. Which means, if it fired 8,000 years ago, the light and the gamma rays are somewhere between there and here, right now. There is no way to know. The radiation and any signal about it travel at the same speed. But WR104 is the one with a name, the one we have studied. The galaxy contains roughly 500 known Wolf-Rayet stars. The actual population is likely higher. The galactic plane is dense with gas and dust, and many of the stars in the inner galaxy are invisible to our instruments from this position. Stars whose distances have not been measured. Stars whose axes have not been measured. Stars we do not know exist. The architecture of this threat encompasses thousands of stars in various stages of terminal instability, distributed through a galaxy 100,000 light-years across, most of them unknown to us in any useful detail. All of them subject to the same collapse dynamics. We have been observing this galaxy systematically for a few hundred years. Wolf-Rayet stars live for a few million years before they die. The population we have cataloged is a fraction of what the galaxy contains, and the Milky Way is still forming stars. New, massive stars are still being born in the dense regions of the galactic plane. Some will become Wolf-Rayet stars. Some of those Wolf-Rayet stars will collapse and produce bursts. We cannot predict which. We cannot observe the interior dynamics of a star from the outside. No instrument reads the rotational state of a stellar core before it collapses. The warning, if one were even possible, would travel at the speed of light. The thing it was warning you about would also travel at the speed of light. Gamma-ray bursts do not announce themselves. A Wolf-Rayet star does not dim or flicker in a pattern that signals imminent collapse. Astronomers can identify stars structurally capable of producing a burst, which is why WR104 is studied. But the timing of a collapse is not accessible to current science. The collapse happens in seconds. The jet forms in seconds. The radiation leaves the system in seconds. And then it crosses the galaxy in silence, undetectable by any instrument anywhere until it reaches a detector. Everything traveling at the same speed. If a gamma-ray burst from a nearby source reached Earth, the first indication would be an anomalous spike in gamma-ray detectors in orbit. There might be a brightening in the sky in the direction of the source. The atmosphere would absorb much of the initial burst. You, standing outside that morning, would not notice. The sky would look like the sky. You would not feel anything. Your body would not register the gamma rays absorbed above you. You would go inside. Above you, 8 kilometers up and higher, the chemistry would have already shifted. The nitrogen oxide chain reactions would already be underway. The ozone molecules would already be reacting. The consequences would arrive slowly, over weeks and months. Sunburn rates would increase. Crop yields would decline. Phytoplankton populations in the ocean's surface layer would begin to fall. By the time the scale of the event was undeniable to everyone, the cause would be irreversible and complete. The universe does not announce its worst events. It issues them. The announcement and the event are one. WR104 is above you right now. Not directly overhead, not necessarily pointed at you, but in the sky, in the direction of Sagittarius, 8,000 light-years away. The ozone layer above you is 3 millimeters of chemistry. That is the distance between the surface of this planet and the lethal UV output of the nearest star. That thin layer of reactive molecules is why anything moves, breathes, or reproduces on this planet's surface. And between you and the edge of a dying star, 8,000 light-years away, that same 3 millimeters is, once again, what stands between the surface and the radiation. The Ordovician extinction happened. 85% of marine species is the number the rock gives back. The fossil record went empty and then slowly refilled over millions of years as the survivors rebuilt something from what was left. The universe fired before. It did not announce it was going to. It fired when the star died and the radiation crossed the distance and the sky changed, and life on this planet was reduced to what could hide deep enough to survive the light. The candidates are out there now, named and unnamed, measured and unmeasured, dying on timescales we cannot observe, in directions we can only approximate, at distances where the geometry either kills or does not. The warning is not coming. The warning would travel at the speed of light. The thing being warned about travels at the same speed. The ozone layer is 3 millimeters. The timing has always been luck. If this channel is where you go when you need the universe to be honest, subscribe and leave a comment. If the end came without warning, a single flash of light and then silence, or if it came slowly, weeks and months of collapse that you had to watch and understand, which would you choose? What the vacuum does to your body when there is no longer any atmosphere left to protect you connects directly to what you just heard. That video, what actually happens to your body in the vacuum of space, is on the end card right now. Tap it.